Welcome to the IM2 video lecture on interpreting vertex and standard form. The learning target here is for you to understand how the vertex and standard form describes the same parabola. The success criteria. You should be able to convert from vertex form into standard form, as well as find the solution, roots, and intercepts for a parabola. Let's do an exploration. You should remember these two parabolas from earlier. Notice one is in standard form, which is f of x is equal to x squared plus 2x minus 3. And the other one is in vertex form. G of x is equal to x plus 1 squared minus 4. Okay, so the question leads, how can you go from standard form into vertex form? This is going to be our first example. The process is to expand the parentheses out, then multiply. Please remember that x squared is the same thing as x times x. So here, the x plus 1 squared becomes x plus 1 times x plus 1. Then you can FOIL or distribute x times x, x times 1, then 1 times x, and 1 times 1. That's what that became. Combine some like terms, 1x plus 1x, and 1 minus 4. And there you go. That should be your standard form. So these two in vertex form was the same thing as this in standard form. So please do this practice problem. You are going to convert these 4 problems that are already in vertex form into standard form. Let's do the first one. I'm going to show this in detail. So the 5 is going to be multiplied by expanding the x minus 2 out because it was squared. So it becomes x minus 2 parentheses and x minus 2 parentheses plus 7. I'm going to take care of the inside first. So x times x becomes x squared. Then x times negative 2 becomes negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 here is positive 4. Okay, plus 7. So in these brackets are just me taking care of the distributing here. Now I can distribute the 5 to each term. So 5 times x squared becomes 5x squared. Actually, let's simplify the inside stuff first. So this can be simplified, okay? So inside, it should just be x squared minus 4x plus 4. Close the bracket, plus 7. Now I'm going to distribute. So distribute to each term. 5x squared, then 5 times negative 4x becomes negative 20x. Then 5 times 4 becomes 20. Then you have the plus 7 in the end. Now these two can be like terms, so this becomes 5x squared minus 20x plus 27. Check your answer. That is correct. All right. So this is the process all in steps. Now I'm going to do 2. I'm going to pause and I'm just going to display the answer with all the work. Okay. Here is the solution for number 2, and here are all the steps if you would like to double check your work. Let me show you 3 and 4 now. Again, same process from before. And these are all the steps for number 3, and here are your solutions. Again, please try this first, then review the steps. I just want to show you all the steps, but again, you need to practice this. Let's do number 4. And this is your number 4. Here are all the steps. And that is your solution. Next, let's talk about the connecting intercepts and zeros. If I ask you to find the zero of each of this function. So remember to put it in standard form. And in this case, I'm going to subtract 3 to both sides. I'm going to get x squared plus 2x minus 3 equal to 0. Graph the related function. F of x is equal to x squared plus 2x minus 3. Notice that here, the x-intercepts, that the solutions, the roots, and x-intercepts, these three words are all the same. So it was x is equal to -3 and x is equal to 1. These are your solutions. You could also say that these are your roots. These are also your roots, as well as you can say these are your x-intercepts. Each one of these, you are going to graph and find the zeros for each of them. You're going to use Desmos, right? So let's put this in vertex form. Actually, let's just move this over. So add 6, add 6. So this becomes 3x squared minus 3. You can graph this now. F of x can be equal to that because it's now in standard form. Okay, it should look like what is in red here. And you should see that vertex, you could see that the parabola's solutions are at -1 and 1. Here, let's put this into standard form for number 2. So add x squared to both sides. You get x squared plus 2x minus 3. That's what the function you're graphing. I have it already here. I saw my solutions are going to be at -3 and 1. 3 and 4 are already in standard form, so I can just graph it. Okay, set it equal to f of x. And I saw that for number 3, the solutions are at -4 and 0. Oh, -4 and 0 or -4 and 4? Let's double check that. Hold on. Let's see. X squared minus 4. It's at -4 and 0. So the solutions here are, this one's wrong. This should be at 0. Okay? Because we graphed it. Right? So x squared minus 4. Perfect. And the next one, let's just graph that on Desmos. I already have it up. Oh, wow. This doesn't intersect. Notice, it doesn't intersect the x-axis. So you can say this one has no intersection, therefore there are no real solutions. No real roots as well. All right, so there you go. Those are all your solutions.